Welcome back. We are still on our offset boring head part number 1 project. So we've already completed just the general outline or mass of our part. We've gotten our extrusion in here, based our extrusion off of that sketch, right? Made an extrusion, then we just added some chamfers on there. So our next step in this is to add some. So our next step in this is just to add some some holes. So in this case, we have holes coming from all sorts of different angles. Right, so we have a bowl hole circle on the top. We have a hole that goes all the way through. We have some counterbore holes that go through this slot to basically allow us to clamp this onto the shank of our boring head. Allow us to slide and clamp it and all that stuff. So our first step, let's do these holes coming in from the side. So these are counterbore holes that are counterbored up to this slot, and then on the other side of the slot are drilled and tapped. So basically in this operation, what we'll do is we'll drill and tap all the way through, and then we will just create a counterbored hole on this side of it. So when you're actually making this, you could make this before or after you put it in the slot. It shouldn't really matter. There's enough meat on there, and you can hold this in the vise well enough that I don't think it'll really be an issue, but you know, your mileage may vary. I don't think that there's really going to be a huge difference doing it one way or the other. So you can kind of decide how you want to do that. So like I said, we're going to start off with these counterbore holes. So let's get going on that. So in order to put these counterbore holes on there, we're actually going to use a new feature of this called the hole wizard. So we know we want to go in from this side. So what I'm going to do is I'm just going to click on this side. Well, what I always find is easiest is to try to orientate my view so I am looking at my side that I'm putting geometry or drawing on or whatever. So I'm looking at it from a perpendicular direction, right? So I'm looking straight up or straight down on this part. So I can do that through our normal view selection tool, right? I can select the side of the cube I want. So I'm going to select that side, or I can right click on that side and normal to, right? That'll do the same thing. So if you've been wondering why I keep talking about what a normal vector is for a plane, this is why, because you use it all the time in CAD. All right, so let's see. So, like I said, these are going to be 2 counterbore holes. So what I'm going to do first is, like I said, they're counterbored at the top up into that slot, and then they are drilled and tapped. So I'm actually going to make this exactly how I would. I'm going to draw it exactly how I would actually make it in the real world. So I'm going to do a tapped hole. So when I click on Hole Wizard up here, and this is in features, I click on Hole Wizard. This is the hole specification manager that pops up, right? This is my property manager. If you have favorites, you can load them in there or save them, whatever. Yeah, if you had like a special type of fastener that there was not a common one for, or you size holes specifically, or more specifically than the general sizing, then you might have favorites. I've not really messed around with them too much because I just use the standard sizes. So if we look at our print, these are going to be 1/4 holes, and they are going to go 7/8 deep. So so we're going to say this is going to go 1 inch. So this first deal here, this is how deep the actual drilled hole is. So when you do a call out, when you make a print, it's going to use these dimensions to define that hole call out. So obviously, you know, we have to select the correct correct thread sizes. If we wanted to select a different thread percentage, we can select that. It's just going to default to our standard tap drill for number number 7 for a quarter 20. Excuse me. So we're going to go an inch deep with the drill, and then we're going to go 7/8 deep with the thread. And then down here, this is basically going to say, how is this going to look when we actually create our model? I would recommend doing either just tap drill diameter or with a cosmetic thread. What that'll do is I'll just show a construction circle around the tap drill hole. So I'll make a hole the size of your tap drill, and it'll make a circle the size of the thread. So I'll kind of give you an idea of, is this thread actually going to intersect with maybe a cross hole, right? A hole that's running in an opposite direction or something like that, or a parallel hole or something like that. It's just, you can do a remove thread, so that'll make the the thread hole, in this case, it would make the hole a 1/4 inch wide rather than the 201. Excuse me. Anyway, so we have our designations for these holes, right? They're blind thread. Excuse me. Like I said, they're a blind thread, so we have to define how deep they're going. If we don't, they will just set to the default, which usually is double depth for, or usually is 3 times depth for your threaded hole and double depth for your thread. This is a little bit different because of how this hole is. And then once we're there, this is just going to include these options when you have a, when we make a print later on, it will say when we have that thread, it'll include the thread class like a 2A or 2B in this case, with thread callout and all that stuff. So positions obviously is going to be pretty self-explanatory. So what it's going to do is it's going to ask you what face you want to put this on. So, and that's most of the time, this is how we're going to want to do it, right? We're going to say we're going to put holes on this face, we're going to go this deep and this size and so on. Occasionally, we will want to put holes on multiple sides of a part. In that case, we would want to do a 3D sketch, and then you can basically put holes wherever you want. It's not really what we're looking for right now. So once we select our side, then it's going to ask for a hole position. And then this basically works just like any other thing in Solidworks. We can put these wherever we want, and then later on kind of change them after the fact, which is really the way to do it. So in this case, I have my 2 holes here, but what I'm going to do is I need to kind of give them some definitions, right? So first thing I'm going to do is I'm going to say, hey, these holes are supposed to be horizontal, right? So now when I move one hole, both holes are going to move together, at least horizontally, right? So from here, I'm just going to dimension these guys. So these are going to be 1 inch 170 apart, dimension. And if I look at my print, these are actually centered on my part. So again, I'm going to select the midpoint of this line, and I'm going to use a construction line or a center line down the center of this guy. All right, and I do that so I can select that center line. Oops. So I can select that center line and those 2 holes. I'm just going to say symmetric. All right, so automatically that's going to put that right in the center, which I guess technically from the print is not correct, but I'm going to go with it because it doesn't make any sense. All right, so then this hole is going to be up 640. Sometimes it's super weird because you actually put the hole where it's supposed to go. or very close to it, and it doesn't really change. All right, so we're going to click OK. I'm going to click OK again. And now we have these holes going all the way through. Or not all the way through, but they're going at least past that slot. So we can kind of look inside that hole. So front side of our part, first half of our hole, that is the back side of the slot, and then we have the bottom of that hole. So this is the only portion that will remain threaded because we still need to make our counter bores on here. All right, so if I go back to here, so I have my number 7 drill and tap. I have my 1/4 20 7/8 deep. Now I need to drill 9/32 by 1/2 inch deep. Well, it's going to go more than a 1/2 inch deep because the center of that, the edge of the slot is 5/10. And then we're going to counter bore 13/32 times 1/4 inch deep. All right, so that's going to be able to accommodate the head of a 1/4 20 socket head cap screw. So I'm just going to normal to that guy again. I'm going to go back into the hole wizard. This time, so last time I selected a straight tapped hole. This time I'm going to go one above it and select a counter bored hole. So here we have our standards. We have inch metric, you know, all your favorites. Hopefully for obvious reasons, these are ANSI inch, and then we're going to go down to socket head cap screw. We're going to select that from our list. And then we're going to select our size. So if I do a normal fit, you can see my drilled hole is going to be 266, which is not a 9/32 drill. 9/32 drill is 281. So what I'm going to do is I'm going to go from a fit from normal to loose. And if you notice there, now I'm at 281 for my through drill. A 32nd inch for a 1/4 inch drill is quite a bit of room. So yeah, it's not something I really need to worry about, really. And then it's going to default to 7/16, which would be 14/32, but we are looking to make this to the print. So that's going to be 13/32. So if I put 13 over 32, hit enter, it'll do the math for me automatically. Isn't that fun? All right. So down in here, end condition, that is for the end of this threaded hole. So we're just going to go up to next. So up to next is basically going to say, hey, we're going to go through the solid and we're going to go up to the next instance where there is no solid. All right, so the next instance where there's no solid, for obvious reasons, is this slot. So I don't have to do this. I could put it as blind and then put in, 0.510 or whatever. But up to next will kind of make life a little easier. Down here, we can add head clearance. So head clearance is going to add a little bit of depth to that counter bore, just to provide a little bit of clearance between the top of the part and the top of that socket cap screw. Near side countersink is going to put a countersink in between the counter bore and the hole. I'm sorry. Near side countersink is going to do a countersink at the top of the counter bore. The underhead countersink, that's the one that'll put a countersink underneath or in between the counter bore and the hole. And a far side countersink is going to put a countersink on the opposite side of the hole. You can use these. The problem with these is they will always be included when you do a hole call out, which is typically not what we're looking for. So usually I don't like to include that, but again, your mileage may vary. So before I get too far, I'm going to orientate this so I can see it a little bit better. And you'll see why here in a second. So for positions, I'm not going to select a spot on here. I'm actually just going to select my circle. All right, so if I put it on the circle, what that's doing is this creating the center point of this hole is going to be coincident, right? Remember that term. The center point of this hole that I'm making right now is going to be centered on the center point of the previous hole. So if I go back in and I have to move these holes, I only want to dimension these one time. because if I go in back in, if I dimension these separately from the original holes, and I move the original holes, these will not move with those original holes. So, but if I do make them coincident, like I just did, just by clicking on that hole, then that will preserve that association. All right, so I can click OK. And now, oops. So up to next did not work out very well, did it? All right, so we'll change that. So instead of doing up to next, we're going to go up to surface. And then when we select that, it's going to say, hey, all right, well, what surface do you want to go to? So I just want to go up to this surface here. And I'll click OK. And now, yeah, that's what I'm looking for. That's much better. I like that better. So as we can see, if we look in that hole, so now we have the front face of this feature. We have the counter bore, the bottom of the counter bore. This is the cylinder that is the 9/32 hole. Then we have our slot, right? So if I click around here, I can see, right, that's my surface. There's my drill point. And then we have our threaded hole on the other side. So one of the things you might notice when you're doing this is as you go through, when you do a hole wizard, you'll notice that there's at least 2 sketches in here. So it's the first sketch underneath it, and it doesn't really matter what kind of hole you have. For this first hole, right, for our core 20 tapped holes, our sketch is going to be basically the geometry of where these holes are. So sketch 3 for this guy, because this is the third sketch in my part. That's going to be sketch 3. So sketch 3 for this is going to be the location of these holes. And if I click on sketch 4 and turn to the side, well, now that is, if you notice, this is a 201 hole going an inch deep, right? So basically we have the geometry of the drill for this. Then we have our hole thread. Oops, hole thread 1 and hole thread 2. So for these, there'll be because we selected the cosmetic thread, it's going to display that construction circle. So that's what that sketch is. And then same thing with the counter bores, right? So sketch 1 is just going to show us where these holes are located. I'm sorry, sketch 5. And then sketch 6 is going to give us the dimensions of this. So another cool thing that we can do is we can actually go in and edit these dimensions as well. So say I wanted to make this 415 instead of 406, right? I can do that there. And I can change it back. So that's 13/32. Right, but those are done. Right, so now we have our side holes. So if, ooh, shoot. Well, if you have any questions, you can get back to me. Sorry, I didn't realize that I had this window blanked out. So, like I was saying, I'll just go back through it real quick, right? Sketch 3 for my hole wizard, for my core 20 holes, that's going to be my location. Sketch 4 is going to be the dimensions of those holes. Thread 1, thread 2, this is basically the locations and how deep those threads go. And then for counterboard holes, right, sketch 5 is going to be, again, the location of those holes, and sketch 6 is going to be the dimensions of those holes. And like I said before, we can go in and we can change these here, or you can change, the dimensions here, or you can go in and you can change these dimensions in our feature manager. So pretty straightforward. All right, so if I go back to here, now I got these 2 holes. Now I need my bull hole circle here, right? So I'm just going to normal to this side, and you'll notice this is one of the things, this is like the big mystery of SolidWorks. I really have never really understood why I can never get rid of these altogether. It's like sometimes they display, sometimes they don't. But you'll see the geometry for these holes is there. Still have not figured out how to get rid of that. So somebody does, let me know. I would love to know because it's more annoying than anything. But anyway, okay, so we are going to go in there and we need to make a bolt hole circle. So these guys are going to be, let's see. So these guys are 1/4 holes. And then it's going to have a counterbore in the center for a pin. Right? Yeah. Yeah. So this is a counterbore hole that has all that going on. Sorry, I'm trying to figure out what this is. There's like a little hole there for that I just noticed. Never really noticed that before. That's in none of the other prints or views. So I don't know what that is. It's a mystery hole. Mystery circle. All right, so let's go back to SolidWorks. There we go. All right. So now we're going to add these 1/4 holes up top. So back to the hole wizard. Again. So in this case, we're going to go to 1/4 again. These are blind holes. So we're drilling and tapping a 1/2 inch deep. So we'll leave it at about 5/8 for drilling. Then we're going to select our surface. All right, so now if I come down here and select down at the bottom, I'm not selecting, but I'm just kind of mousing over, hovering over. So once I find that midpoint, if I go up, it will snap to it and keep it on that line. All right, so if I go up, I can go up all the way to that point right there. Now, I probably don't actually want to do this, so what I'm going to do is I'm just going to put one hole, and then I'm going to actually create some center lines. So if I create center lines that are going from midpoint to midpoint, horizontally and vertically, that I'm basically putting the cross of this right where the center point is. And so from here, I could individually put these holes up, but what I'd like to do is do a sketch pattern. Right, so we've done sketch patterns before. Usually they're transforms. In this case, we've done mirroring. There's linear sketch patterns, pretty self-explanatory, and circular sketch patterns. So circular sketch patterns are basically selecting our whatever we're going around, and then we are selecting where that center point is. So right now, all right, why is that not working? All right, let's do circular sketch pattern. Let's select that first, maybe. Let's try that. And then why? Don't know why it will not let me select a new part. All right, let's try this again. So we're going to try this a different way. So this is on a bolt circle that is 1.5 inches in diameter. So I'm going to take this guy and I'm going to dimension it 3/4 of an inch away. Alright, so then if I select this guy and then do a circular sketch pattern, and I can say this is going to be 1.5 inches. Well, that's radius, so we're going to say 0.75. We're just going to put that right there. And then for instances to skip, I'm just going to I guess I'm not going to skip that guy. I'll click OK, and now we have 5 holes. All right, and we kind of have that holes little. So we have 2 holes that are intersecting just slightly. This hole's intersecting slightly with that other one, but I'm not worried about it. I think it'll be fine. All right, so we got that going on. We have our hole pattern there, and now we need to put our counter bore in. All right, so sorry, I was just reading this call out. So if I look at my call out here, it's pretty big call out for one hole. So we are drilling number 7 through, and then we're going to counter bore it 5/16, 610 deep, and then we're going to counter bore it again 3/8 diameter, 300 thou deep. So again, I'm just going to do a hole wizard, and I'm just going to do a you know what? I'll just do a legacy hole. So if I do a hole type, it's going to want to select and give me features based on what kind of screw is going in there. Alternatively, I can do what's called a legacy hole. So legacy holes are basically how holes were handled by Solidworks a long time ago before I ever started using it. So they started doing these holes where they size these all to screws probably 5 years ago. When I first started using SolidWorks, I don't remember having that. Or maybe I just didn't know how to use it. But what we can do is do a legacy hole. Legacy hole is going to be basically just a basic counterboard hole, right? So in this, we can change this. We'll say 201 diameter. We'll say up to surface. And we'll just say through, because that's going to go through all. All right, so it's going to go through all. Then we have our counterbore diameter. So that's going to be 5/16. The counterbore depth is going to be 610. And then for positions, we're just going to select our face, and then I'm going to select that center hole. Click OK. All right, so now I have just a little bit of thread in the very bottom of that hole. And then I have a fairly deep counter bore. All right, and I'm just going to do a hole wizard again. Same thing. Counterboard drilled. We'll just do counterboard drilled again. Still 201 on our diameter. Still through all. Then for our counterbore diameter, we'll do our second counterbore. So it's going to be 3/8. Oops. So that'll be 3/8. And that's going to be 600 deep. Nope, sorry. 300 deep. And then we'll select our top surface, and then we're just we're going to select the center point of that circle that we already have. And so now if we look down into that hole, we have our quarter 20. There's our thread, right? So this is going to be a 201 hole. That's going to be our thread. This is our 5/16 counter bore. It's down 600. And then this is our 3/8 counter bore. It's down 300. So one of the cool things is you don't have to take my word for it, right? Or your word for it. You don't have to go back in here and say, all right, is this perfect? I think it is, but I'm not sure. So another kind of cool feature we have with Solidworks is the Evaluate tab. So up top with the Evaluate tab, we have a whole bunch of different functions we can use. Everything from checking for interference. Where is that? We'll see it. Anyway, we can check for interference or clearances. We can check geometry. We can see, where the curvature is on stuff. We can make sure that there aren't errors in here. We can look at section views and see what's going on there. Mass properties is what I was talking about earlier that says, what can we see with this? Where it'll look at the model, say there's this much solid mass in this model, so this part's going to weigh this much. But also look at the size and shape of the model and calculate things like where the center of gravity is. That was actually something that was really useful when I made the tops, when I designed the tops that we've been given out, because I was able to see where the center of gravity is. Because with the top, you want the center of gravity as low as you can get it, so it's as stable as you can get it. But one of the best things, or one of the most useful things that you'll use is the measure function. All right, so the measure function basically is this little ruler tape measure thing. So we can either measure individual, and unfortunately I don't think this is probably going to show up correctly on my screen. No, damn it, did it again. All right, so on our evaluate functions, right, we have all these different functions, like I said, but the measure function is going to be what I want to do. So when we go to measure, we get our little tape measure guy. So what we can do is we can click on multiple entities or different parts of geometry to get distances or angles, but we can also just click on individual things, right? So right now, if I click on that, it's going to show me the area. Right, so it's showing me the surface area of that cylinder. It's showing me the diameter and the perimeter of it. Right, so show me all sorts of information. If I click on two different features, well, now it's going to show our delta Z. Right, so that's our change in Z. I drew this from the side, so that's why we have a delta Z, delta X, and minimum distance. But we can change that. We can change that to center distance. Minimum distance is going to be from edge to edge. Maximum distance is going to be from opposite edge to opposite edge. Custom distance, we could do some combination of those. Usually we want center distance, though. That's usually what we're looking for. So like if you want to know the chord length of this bolt hole circle, right? The chord length would be the distance from center of one hole to the center of the other. Or, I think that's chord length. Anyway, if it's not, correct me. Correct me in the comments. But anyway, right, we can change all sorts of stuff with that. But what that allows us to do is we can, and if you, like say we're in here, we're measuring this, you're like, I don't want this anymore. Rather than clicking out of this and clicking back into it, because this still stays highlighted, just click anywhere in white space. Right, if I click in white space, it's going to reset it. So from here, I can say, all right, how far are these 2 points away from each other? All right, so it says 1.5 inches. Well, what you can't see because it's in a little pop-up window is actually a little bit more information in there. So it'll tell you, different deltas. If I measure two surfaces, it'll tell me like the angle in between those surfaces. So the angle in between those two surfaces is about 60 degrees. Well, not about, it's exactly 60 degrees, right? Which makes sense because that's the included angle. That's 60. That's 60. That means that that's an equilateral triangle, right? 60, 60, 60. So anyway, the evaluate tab measure tool can be very, very useful for you. It's a lot quicker than going back into your feature managers and just figuring out, do I have all these dimensions correct? This is a really easy, really quick way of double checking your parts after you draw them up to make sure that they are the sizes that you want them to be. So anyway, I think that's probably a good stopping point here. If you have any questions, please email me, leave them in the comments. Emailing me is probably the best way. And like I said, we will continue this on tomorrow. If you do have any questions, email me. I will try to get all your questions into the live stream for tomorrow. Hopefully it works out a little bit better today or tomorrow than it did today. Worked okay at first, but then taking that pause seemed to break it. So anyway, thanks for listening, and I will see you guys later.